Hello, dear students. Welcome back. See, in the soil chemistry, in previous session, we have discussed about what are the types of nutrients, okay, and what is organic matter, and what are the various functions of these nutrients and organic matter in the soil. So today, we will discuss about the parameters, the physical parameters, and the nutrients which are present in the soil, how they can be determined. See, we will discuss particularly about the determination of pH of the soil, which plays a very important role in soil, and then we'll discuss about the determination of the organic nitrogen present in the soil. Okay, so first we'll see how the pH of the soil is determined. As you are aware of, pH is nothing but it is a potential of hydrogen, means it measures the hydrogen ion concentration. It is given by formula as pH is equal to minus logarithm to the base 10 of hydrogen ion concentration. Actually, the pH is the indicator of the acidic property or alkaline property of the soil. If the pH is high, the pH is high, okay, that means soil is alkaline. If pH is low, the soil is acidic. pH is 7, the soil is neutral. Okay, see, this is how the pH it can be defined. Now, how the pH will play an important role in the soil chemistry. See, for the plants to grow healthy, the desirable pH range is between 6.2 to 6.8. If it is in that range, it is slightly acidic. Okay, not neutral, slightly acidic pH, 6.2 to 6.8. Then it can be a good pH for the for the plants to grow, because at this pH the nutrients will get dissolved in water and they can be absorbed by the plant very much extent. Okay, so that is a desirable pH for the soil. Now we'll see if there is any change in pH. If the pH is low, okay, then it can be increased by adding limestone. Limestone is alkaline. If you add limestone, then the pH can be increased. If the pH is high, it can be decreased by adding sulfur. Okay, if the soil is acidic, it can be acidic nature of the soil can be decreased by adding limestone, and if the soil is more alkaline, it can be made slightly acidic by adding the sulfur. So the pH can be altered by addition of either sulfur or limestone to the soil. Now we'll see how the pH of the soil can be determined. The first step in the determination of pH of the soil is sample preparation. To prepare the sample for the determination of the pH of the soil, there are two methods which are usually followed. First method for sample preparation, number one, it is 1:2 soil water suspension. Or soil water suspension is not solution, because soil is not soluble in water. We have to make 1:2 soil water suspension. How it is made? See, we have to take the air dried soil sample from the field, okay, various parts of the field, and then you have to grind it and then you have to sieve it. Sieve means so, okay, sieve it so that the soil will have a approximately 2 millimeter mesh size. The size of the particles of the soil is around 2 millimeter mesh size. Okay, and then take 40 gram of that air dried and sieved soil sample. How much? 40 gram, and then add 80 ml of water. See, 40 gram, 80 ml. 80 ml means approximately 80 gram. Therefore, it is 1:2 soil water suspension, and mix them thoroughly. Okay, usually the water taken should be a distilled or deionized water. It is not simple water. It should be either distilled water or deionized water. It should not contain any ions, because that will affect the pH. Okay, so 80 ml of distilled or deionized water, and then it is mixed thoroughly and kept it for 1 hour. Okay, this is first method of preparation of the soil as a sample for the pH determination. The second method is the calcium chloride solution. See, here we have approximately 10 gram of the same kind of soil, that is of 2 millimeter mesh size sieved soil. How much? Here it is 10 gram of this soil, and then take 20 ml of 0.01 molar calcium chloride solution. Instead of water, we have to take a 20 ml of the zero point zero 0.01 molar concentration calcium chloride solution. Then you have to mix it thoroughly and keep it for 1 hour. We can follow either of these methods for the determination of the pH. That is first step is sample preparation. See, once again I repeat, for sample preparation, either you can prepare a solution by taking simple water 1:2 soil water suspension, or by taking 0.01 molar calcium chloride solution. Either of these methods have to be followed. Then the second step is determination of pH. The samples should be analyzed immediately. See, after that 1 hour duration. See, then take that solution which is prepared either of the methods. Then measure temperature of the soil. You have to measure the temperature of the soil. Okay, and set the same temperature in the pH meter. pH meter is just like the conductivity meter that you have used in your experiments to determine the conductance. So pH meter, okay, the temperature is to be adjusted so that the temperature of the pH meter and temperature of the soil solution both are matching. Then calibrate the pH meter using buffer solution. Buffer means solutions which are of known pH, which are available in capsules. Okay, so those buffers are used just to calibrate the pH. We have to use that solution and they have to dip the pH meter. Okay, you have to use the pH meter and you have to calibrate the pH meter so that the pH shown and the pH on the buffer solution should be same. So this is just calibration of the pH meter. So after that, okay, rinse the electrodes which are dipped in the buffer solutions with the deionized water and dry them, and then keep the same electrodes in the soil sample solution, okay, or suspension. Then note down the pH. So that gives the pH of the soil. Simple method. First you have to calibrate the pH meter by using the buffer solution, and then the electrodes have to be washed with deionized water and dip the same electrodes in the soil sample solution. You'll get directly the reading. That reading is pH of the soil. So this is how the pH of the soil can be determined by using pH meter. Now we'll see how the nitrogen present in the soil is determined by one of the methods, that is also called as Zeldov's method or potassium permanganate method. This is the organic nitrogen present. The nitrogen in the soil is usually present as organic matter. So how the organic nitrogen in the soil can be measured? See, for this a known weight of soil is mixed with alkaline potassium permanganate. You can take any known weight. Okay, but you have to note down the weight of the soil and mixed with potassium permanganate solution and distilled. It is distilled then. Solution is distilled KMNO4 solution, no, and then soil. They are mixed and distilled. The organic matter present in the soil. What happens to the organic matter in the presence of the KMNO4? Okay, so usually alkaline KMNO4. When it is heated to distill, the organic matter gets converted, okay, into the ammonia. See, in the presence of the nascent oxygen present. Then this distilled nitrogen, ammonia, sorry, the nitrogen in the form of ammonia, it is released into the sodium hydroxide solution. Okay, distilled one, it is released into the sodium hydroxide solution. Okay, and containing the known amount of boric acid with a mixed indicator. So these are the steps to be followed. Once again I repeat here. First, the soil is mixed with KMNO4 solution and it is distilled. Distilled means heated. Okay, the condenser, and it reacts and it vaporizes. The organic matter present in the soil, what happens is oxidized by nascent oxygen liberated from KMNO4 is oxidizing agent by potassium permanganate. In the presence of sodium hydroxide, the released ammonia is condensed and absorbed in known volume of boric acid. Okay, ammonium salt ಆಗಿರುತ್ತೆ, NaOH ಹಾಕಿದ ತಕ್ಷಣ it will form a ammonia. NH3 is a base and it is absorbed in boric acid with mixed indicator to form ammonium borate. Ammonia is converted into ammonium borate. Notice. So what happens? The nitrogen is converted into ammonia. The ammonia is converted into ammonium borate. Okay, the excess of which is treated with standard sulfuric acid. Okay, so now we'll see what all the procedures are to be followed. That is the principle. Okay, now preparation of soil sample. Soil samples from definite depth are randomly collected from the field, from the various parts. Okay, from the four corners and the center, like that, from the various parts of the field, the soil sample is randomly collected. Okay, and it is air dried in the shade, not in direct sunlight, and then it's ground by using wooden rollers. Thereafter sieved through 2 mm stainless steel siever. Okay, so we'll get the soil of 2 mm mesh size. So this is sample preparation. Now 20 gram of that soil is taken in round bottom flask. RB flask means round bottom flask, and 20 ml distilled water is added. Okay, 100 ml each of potassium permanganate. Okay, for 20 gram of the soil it is. So 100 ml of potassium permanganate 0.32% and sodium hydroxide 2.5%. So that will get the alkaline potassium permanganate as an oxidizing agent. They are added into the RB flask containing soil sample and distilled water. 2 or 3 glass beads are added to prevent the bumping, and liquid paraffin oil to avoid frothing are added. RB flask ಅಲ್ಲಿ. So what is added first? The soil is added, water is added. Okay. Then to that potassium permanganate and NaOH are added. It has to be heated. Heat ಮಾಡಬೇಕಾದ್ರೆ ಏನಾಗುತ್ತೆ bumping ಆಗುತ್ತೆ. Okay, so to avoid that bumping, the glass beads are added. Some glass pieces are added, so they will prevent the bumping and to prevent the frothing foam formation. ನೊರೆ ಬರುತ್ತೆ. So ಅದನ್ನು ಅವಾಯ್ಡ್ ಮಾಡಲಿಕ್ಕೆ so some paraffin oil is added. Okay, the above contents of the RB flask are distilled and liberated ammonia. ಅದು heat ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಇವೆಲ್ಲ reaction ಆಗಿ a nitrogen present in the soil in the form of the organic compound is converted into ammonia. Okay, ammonia convert ಆಗುತ್ತೆ. So then the above contents of the flask are distilled. Liberated ammonia is collected in 20 ml. That is to be known 20 ml of 2% boric acid. A 250 ml conical flask. ಅದನ್ನ 250 ml conical flask ಅಲ್ಲಿ ಕಲೆಕ್ಟ್ ಮಾಡೋದು. ಯಾವುದನ್ನ? ಅಮೋನಿಯಾ, ಲಿಬರೇಟೆಡ್ ಅಮೋನಿಯಾ ಗ್ಯಾಸ್ ಅನ್ನ 20 ml of 2% boric acid. Boric acid is an acid as it indicates. Ammonia is a base. They will react and form the salt. That is what is the ammonium borate. Okay. The distillate is then titrated against standard solution. ಅದೇನು ಬೋರಿಕ್ ಆಸಿಡ್ ಅಬ್ಸಾರ್ಬ್ ಆಗಿರುತ್ತಲ್ಲ ಆ ಸೊಲ್ಯೂಷನ್ ಅದನ್ನ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಸೊಲ್ಯೂಷನ್ ಆಫ್ ಸಲ್ಫ್ಯೂರಿಕ್ ಆಸಿಡ್ ಜೊತೆಗೆ ಟೈಟ್ರೇಷನ್ ಮಾಡೋದು. ಟೈಟ್ರೇಷನ್ ಮಾಡಬೇಕಾದ್ರೆ ಯು ಹ್ಯಾವ್ ಟು ಯೂಸ್ ದ ಇಂಡಿಕೇಟರ್. ದಟ್ ಇಂಡಿಕೇಟರ್ ಈಸ್ ಮಿಕ್ಸ್ಡ್ ಇಂಡಿಕೇಟರ್ ಆಫ್ ಬ್ರೋಮೋಕ್ರೆಸಾಲ್ ಗ್ರೀನ್ and methyl red. ಎರಡನ್ನು ಮಿಕ್ಸ್ ಮಾಡಿದಂತ ಇಂಡಿಕೇಟರ್. That's called as mixed indicator. The name is bromocresol green and methyl red. Okay. The sample is heated by passing steam at steady rate, and liberated ammonia is absorbed in 20 ml of 2% boric acid containing mixed indicator. So that's what is the repeated one. Okay. Then the titration is carried out, and then you have to just take the titer value. Titration ಮಾಡಿದಾಗ ಬ್ಯೂರೇಟ್ ರೀಡಿಂಗ್ ಅನ್ನು ಬರ್ಕೊಳ್ಳೋದು. Once again I repeat here, 20 gram of soil sample, then 20 ml of distilled water, to that 100 ml of potassium permanganate, okay, and then sodium hydroxide, then 2-3 drops of the glass beads, 2-3 beads of the glass, and small amount of the paraffin liquid to prevent the frothing. So they are heated and distilled, and ammonia is collected in 20 ml of 2% boric acid. Our distilled solution, okay, it is then titrated against the sulfuric acid, and titrating is taken. Okay, now these are the reactions that are taking place here. So first, as an oxidizing agent, KMNO releases the nascent oxygen. The nascent oxygen reacts with the nitrogen in the soil to form the ammonia and other oxidized substances. Okay, this ammonia is with the water, it will form ammonium hydroxide, and that ammonium hydroxide reacts with the boric acid to form the ammonium borate. the ammonium borate with sulfuric acid when it reacts. Okay, so you'll find out the ammonium sulfate convert ಆಗುತ್ತೆ. Then you'll get the when it's completely reacted. Okay, the color change occurs and you can note down the titer value. Okay, with using that titer value, you can find out the amount of nitrogen present in the soil by using this formula. ಇಲ್ಲಿ R ಅಂದ್ರೆ ಟೈಟರ್ ರೀಡಿಂಗ್ ಬಂದಿರೋದು ಬ್ಯೂರೇಟ್ ಅಲ್ಲಿ. ನಾರ್ಮಲಿಟಿ ಆಫ್ ದ ಆಸಿಡ್ ಸಲ್ಫ್ಯೂರಿಕ್ ಆಸಿಡ್ ನಾರ್ಮಲಿಟಿ ಕೊಟ್ಟಿರ್ತಾರೆ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಒನ್. Then atomic weight of nitrogen is taken as 14 and weight of 1 hectare of the soil. The weight of the hectare of the soil approximately divided by sample weight that we have taken 20 gram into 1000. ಈ formula use ಮಾಡ್ಕೊಂಡು you can find out the amount of available nitrogen. Okay, kg per hectare. So this is the formula. So this is how the pH and nitrogen of the soil can be measured. Thank you.